Okay, so let's get started. Well, all of you probably have heard about even integers and odd integers and what they are. And the property of even integers are integers with last digit of 0, 2, 4, 6, or 8 are even, and they could be written in general form 2n because of the definition of an even integer could divide into two equal groups. Where n is any integer.
Can you make it larger, please?
Sure. This is good.
Yes, thank you.
And here are examples of two-digit even integers with tens digit 1. And odd integers have the last digit of 1, 3, 5, 7, or 9. And they could be written in the form of 2n plus 1 or 2n minus 1, because for odd integers, they're not even themselves, but if you add one or subtract one from it, then it becomes an even integer. Here are the odd integers with tens digit of 1. So parity is a word to describe whether a number is even or odd. An even number has even parity and an odd number has odd parity. And studying whether numbers are even or odd could lead to intriguing and insightful finds. For example, here are arithmetic properties. A even number plus a even number will be a even number, which, for example, 12 plus 14 equals 26. So you could write them in their even form of 2n, each of these. You could factor 12 from each and see that this is even, which is 2 times 13, which is 26. And an even plus an odd is odd. For example, 12 plus 13. Because you could just write it as two even numbers and then plus 1. It's 13 is an even number plus 1. Then make it even times even, in this case 12 plus 12, which is 24, plus 1, which makes it odd. And similarly, an odd number plus an even number will be odd because of the commutative property of addition. While if you add two odd numbers together, it'll result in an even number. And you could say this case for 13 plus 13, since you could actually write them into the sum of even numbers. You could write it actually as 12 plus 1 plus 14 minus 1, which are two even numbers. And that equals 12 plus 14 when you cancel out the ones. So that's even plus even, which is even. And basically, to keep in mind, if the number of odd integers is even in sum, then the sum of them is even, since if you look, adding a sum by an even number does not change its parity, since you add a multiple of 2, which will make it the same parity. But if you have an even number of odd integers, you could also group them into 2's, then make another sum of even numbers. While if the number of odd integers is odd and the sum of them is odd, and you can see this because, let's say, just first assume the number of odd integers is even, you take away an odd addend in it, and then if you, that's even, and then if you add that odd addend in, that's even plus odd, which is odd. And as you could see, similarly, also reflects in multiplication properties. Odd times odd will equal to odd. We could see this, for example, it's called the odd numbers m times n, which you could factor as 2m plus 1 times 2n plus 1 equaling 4mn plus 2m plus 2n plus 1, which equals 2 times 2mn plus m plus n plus 1. You know this part is even, then it's plus 1, which makes it odd. For example, 15 times 15 is equal to 225. And also, an odd number times an even number is even, and so is an even number times an even number. And just a property to keep in mind, actually the product of any amount of numbers, if there's at least one even factor, then it's even, but if it has no even factors, it'll be odd. Since you could see, it's called a number a times b, and we say that a is even and b could be either even or odd. And then let's substitute, because a is even, a could be written.
Either way, if b is even or odd, but the number that the result is going to be even.
Yeah. That's true. So I'll quickly demonstrate it for those who want to. Just write this as 2 times bn, which is equal to 2 times bn, which is even. For example, you could see them in 11 times 12, which is 132. And also, for dividing two integers, the result is not always an integer, but if it is an integer and it's odds divided by odd, it'll have to be odd. And you can prove this by contradiction. Let's assume it's number odd and then divide by odd. Let's say, what if it was even? Well then, let's see if that means that an odd number must equal an odd number times an even number. We times this one here. And we could do that since odd numbers are not zero. But then if we look at now this part, odd times even, we're given that that must be even since it has an even factor. But then odd cannot be equal to even. Therefore, odd divided by odd must be odd if it's an integer, such as 1001 divided by 11, which is 91. You could try dividing it out for yourself to see. And to keep in mind, the sum of any and even integer and one is odd. That's basically straightforward. Since if it's even, then you add one. By definition, it'll be an odd integer. Any two consecutive integers have opposite parity. That's similar to the first statement. 12 is even, and then 13 is odd because numbers right next to each other will have different parity. Also, a plus b and a minus b have the same parity. because actually parity exists for negative numbers too. And they actually are the same parity. For example, because 0 is even, but then if you, for example, 1 that's odd, and negative 1 is also odd because it's the same distance from 0.
What's a parity?
Parity, it's here. It's like basically a word that describes studying whether numbers are even or odd.
Oh, thank you.
No problem. So, for example, if you add A plus B, if B is even, that won't change the parity of A. But if you do A minus B, if B is even, also won't change the parity of A. Since it's hard to explain with words, but you can imagine, or just like out of something like 6 minus, or in this case, 15 minus 5, 2. We're just taking away each of these two. Minusing multiples of 2 does not change the parity, right? Similar to adding them. While if it's odd, for example, in this case, 15 minus 5, that's, you'd write it, it's just pretend it's odd and it's already 15, although it's not. And if it's subtracting groups of 2, and then since 5 is odd, you then subtract a 1, which makes it even, changes parity, similar to when you add 1, since you add 1 here, and then add multiples of 2, which doesn't change the parity, but adding 1 changes the parity. Is this clear for all of you?
Okay.
Good. The sum of two consecutive integers is odd, since it must be odd plus even or even plus odd. You can see this, let's call the first number n, the next number n plus 1, regardless if n is even or odd. Then that will equal to 2n plus 1, which, as we know from the general form, it's odd number, like 12 plus 13. While the product of two consecutive integers is even, since it must be even times odd, which has an even factor, like 12 times 13. If you try multiplying it out by hand, you get 156. Now let's look at some problems. Try to solve the first one. I'll give you a few seconds to think about the method. Okay, now let's see. One of you chat me odd. So if we want to do, there are actually, you could approach it in a few ways, but for example, you could approach it by first and last term, second and second last term. But for my review, we'll look at consecutive terms. From n to n plus 29, since this is 29 and then plus 1 is 13.
For this problem, wouldn't there be an even number of, like the same number of even numbers and the same number of odd numbers, so the even numbers pair up and the odd numbers pair up, and then they add to be odd, maybe?
Yeah, that's a good way to approach it. I actually haven't considered that much, but yeah, you could look at it like that. Since there are then 15 odd terms, and there are an odd number of odd terms in the sum, which makes the sum odd. And also another quick way to do it is grouping them, and you see each of these, since they're the sum of consecutive integers, there are odd, and there are 15 of them, which also produces an odd number. Now take a look at the second problem. Any of you have ideas? Okay, sure. Yo, do you want to explain how you solve the problem?
I thought of it as the same way the problem was before. There's an even number of numbers, which means there's an even number of odds and even number of evens. And then once again, if you add them up, it would be odd, but I don't know.
Okay, that's exactly how you should approach it, seeing how many numbers of odd are there, whether that value is even or odd. So you first find the lowest multiple in that range 20 to 100, which is 21, and the highest is 99. And then you factor them as 3 times something. As you can see, both of these are odd, right? And now these, all the terms, you could actually ignore the even terms. And even terms are basically 3 times an even number, since that's even times even. So skipping 3 times 8, you go to 3 times 9, 3 times 11, and so on, 3 times 33. And then in order to count the number of terms in the sum, you do first 3 minus 37 over 2, you actually divide by 2 because these are counting by 2's. And then plus 1, because this part accounts for how many skips you do. So amount of leaps over here will be this amount, but then you also have to count for the first term. And then if you do the arithmetic, that's 14, I believe. And that's actually, if you see, that's an even number of odd numbers, which will actually be even. Yeah. Good job trying, any of you that attempted it. And yeah, it's good to have the insight to know the method just counting how many odd numbers are there. Okay, now the third question. Sure. Yo-Yo, I believe you're correct. So for doing this problem, instead of listing out the actual values, you can list them with their parity. It's the Fibonacci sequence. Start from odd, and then no, these you just know from arithmetic properties. Next would be even, and then next would be odd plus odd, just odd, and then odd, even, odd, odd, even, and then list them until you realize a pattern. In this case, you see it'll always be odd, odd, even, repeated. And then there's 63 terms, and that means there's our 24 repeats of odd, odd, even. And out of those, in each of these set of 3, there's one even. So in all there are 21. Now let's try the fourth problem. I'll actually do this one together. So continuing in the pattern, in column will the integer 50 be? So notice that the table lists all the positive even numbers, and that
Find a pattern between the numbers in all of the columns.
What?
Maybe we should find a pattern in the numbers in the column.
Yeah, that's correct. We do look for a pattern here. You can see 2, 4, 6, 8, which is skip counting by 2. And as we see down here, although this goes down, but if you go this way, 10 from right to left, it's 10, 12, 14, 16. You go down again diagonally, there's 18, 20, 22, 24, and 26, 28, 30 there too. And as we see, 50 will be the 25th term since it's 2 times 25. And in the table, we'll see how it goes. It has, for any row that's odd, it'll be counting from left to right, numbers aligned from B to E, while for even numbered rows, like rows 2 and 4, they'll have numbers lined from A to T and counting from right to left. And as we notice, there are 4 terms in a row. And then you could actually notice 25 is 4 times 6 plus 1, which means that before the 25th term, there are 6 rows of numbers terms. Yeah. And 20, as we see, then the 6th row will be an even row, counting this way. And the term right before 50, which is 48, will be here in row A. Count down here. You'll have 50, which is in row B. Do you guys understand? Okay, if there are no concerns, I'll move on. Try doing this one by yourself.
What does it mean by what expression is equal to y squared minus x squared?
Oh, here I can just write it in terms of y. All right. Some of you may have gotten answers on our papers. Yeah, that's close. So the answer is actually for, let's see, sorry. So what you do is write x in terms of y. First listing x, y, they're consecutive odd integers, meaning that they'll have increment of 2. Similarly, to go from y to x, it's minus 2. Therefore, x is y minus 2. Then plugging it in into the equation. You get this. Which then equals 4y minus 4. Which you could also write it, if you want, as 4 times y minus 1. Now, you take a look at the last problem we'll review today. And tell me if any of you have any solutions. Okay, so I got one response in the chat. Let's see. For this expression, you may factor it out as x squared times y squared plus x, which, given that it's odd, means that these factors all have to be odd, must be odd times odd. Therefore, as we could see, x squared is odd and x plus y squared, which this is x plus y squared is odd. Well, let's see too. What if y is odd or y isn't odd? Well, if you see, actually, if y is odd, then y squared will be odd since it's odd times odd. Then y squared, since y squared plus x also has to be odd, x will have to be even to make the sum odd. Then if x is even, that means that x squared must be even too, because even times even, which then that shows that actually y can't be odd and 2 actually has to be false. Alright, now we're gonna go play a Kahoot. And then if we have time, we'll also play my Kahoot from week 2, which we didn't have time to finish.
So, for like the even and odd for problem 6, is it better to write an equation?
For the which problem? Sorry.
Number 6. Is it better to write an equation?
For even odd, yeah, you should write equations for even or odd, or convert, for example, if they're numbers 5 plus 6, you could make them write them as odd plus even to figure out the parity. Does that answer your question?
So when I said that y is odd, I was thinking that, oh, I get it. Because if y is odd, then that product would be even, and x plus even is even. Yes, I get it.
Sounds good. Okay, please join if you would like to play. Okay, do you want me to start now? Or, because I'm still waiting on 3. Okay, can you please either put your real name if you want to be recognized, or to tell me who you are if you put another name? Okay, can you tell me, before we start, can you tell me who's A? Okay, good, got you, Annie. So I'm going to start now. Oh, it wouldn't let me say that, that's strange. But anyways, let's get started now. And if you want to join later, you guys could join later. You guys, you see it's 2A plus B. Since if they're both odd, then you could see quickly A plus B would be odd plus odd, which is even. And A minus B also would be even. But 2A plus B, it's 2A is even, and then plus B, which is odd. Yeah, it's 4 times x plus 3. Actually, it's similar to a problem we went over, except you must write in terms of x and then plus 8 at the end. For example, first y squared minus x squared. If you just do the arithmetic and wrote it in terms of x, this part would be 4x plus 4. And then if you plus 8, that's equal to 4x plus 12, which should be factored as 4 times x plus 3. You. Yeah, nice job, Yo-Yo and Irene and all of you. So the correct answer is 3. For this problem, you may have tried guessing and checking, plugging them in, which works. A systematic method is to factor a square minus b square as a plus b times a minus b, which if you use the FOIL distributive property method, you'll see that works. It's actually a common factoring trick that appears a lot in competitive questions. We're given that equals 7. And since a and b are both positive integers, a plus b and a minus b are both integers too, and a plus b has to be positive. As you could see, you could factor 7 as 7 times 1. And because b is positive, that means that a plus b must be 7, while a minus b is equal to 1. Then if you solve the system equations, you'll get that b is equal to 3. Oops. Good job. Sorry. Yeah. So for this equation, you could just plug in, and try t each time. For example, 2t minus 3, that's equal to even minus odd, which is odd. Well, t plus 4, that's t is odd, and then plus 4, which is even, will still be odd. Well, 5t plus 5, you write it, well, you know 5t is equal to odd times odd, which is odd. That's odd plus odd, which is equal to even. So the answer is 5 plus 5. Good job, Yo-Yo, Irene, and Jenny. And also, good job, Jessica and Annie. Okay. Let's go on now. So now we have 8 minutes left, and we could play the Kahoot from week 2. So this is optional if you girls want to play or not. Okay. If you girls want to join, please join in the next minute, and we're gonna start and have some fun.
I need to go now. Thanks for teaching me. Bye.
You're welcome, Yo-Yo. Also, by the way, a reminder, so the homework will be posted in the questions section of this Camida here. Answer these on Google form I'll create, and also post the directions in the assignment. Okay, I guess there's only one player, but we need at least 2 to join. So do girls want to do the Kahoot? There. I'll start now, but you girls could join in the middle if you would like. Yeah. So for the first question, it's 3 and then point 1 says you know from week 2 any number of the form AB where AB is a repeated decimal can be written as AB, not A times B, but two-digit number over 99. So this would be 3 and 1 over 99. Let's go. Okay, so for this question, you could test each of the numbers out. As you see, the triangle option, that's too small. And while the circle option, that's bigger than both the numbers. They're only 0.5994 times between those two numbers. Good job, Annie. Okay, so for this problem, you just try doing long division, then rounding it, and you would get 0.5. Good job.
What does the slash mean? It has a 0.2525 on, and then there's a slash.
Yeah, that's division. Just don't worry, I'll go over it. So if the notation was confusing, I'm sorry, but this is just basically it means divide. And to approach this problem, we'll write these as fractions. And as you know, this would be 25 over 99. And this would be 5 over 9. So the property that 0.a will equal to a over 9. That actually is similar to the other properties, and 0.a will be a over 99, which is also equal to a over 9. And moving on, by using the sequence for dividing by a fraction, will become 25 over 99 times 9 over 5, which you could divide out to get 5 over 11. Okay, this question is similar to the last problem. For the numerator, it's 27 over 99. For the denominator, let's first write it here as a mixed fraction, then convert it into improper fraction form. This is 3 over 29, which is equal to 29 over 9. write down here. And then convert division to multiplication. Then you'll see equal to 27 over 11 times 29, which the denominator is actually 319. And a quick way to do this would be to see, well, the denominator must be 27, not 9 over 29, since you can't cancel out a 3 in the denominator. And also 11 times 29 is greater than 11 times 9, which is equal to 99. And that's why the answer can't be square either. So this works. Okay. For this, it's multiplication instead of division. And it's 63 over 99. Oh yeah. Sometimes it happens you press the wrong button. And yeah. But that's okay. It's mainly if you understand the concepts, that's good. And so for explanation, I won't go over the explanation more, but you just convert them to fraction form and convert 3.666 so on into an improper fraction and multiply. And I actually think we'll end the game here since it's already 12:05. And see you, girls. Thank you so much for coming to my class.
Thank
And
you.
you're welcome. And let's see. Okay. Good job, Irene, Jessica, and Annie.
Bye.
Bye.
Bye, everyone.